These are the notes for lesson 6. Complex numbers. Our objective in this is to perform operations with complex numbers. Of quadratic functions, we have the Nevada standards here that we'll be covering. Complex numbers consist of a real number and an imaginary number. The imaginary unit is represented by I, which does represent square root negative 1. So the negative inside the radical becomes the I with a root 1. Root 1 is 1, so 1 times I is where I comes from. And then we have I squared is negative 1. Either remember that fact or realize the reason behind it is I is the square root of negative 1 squared, and then it's equal to negative 1. And then squaring a square root would cancel it, giving us negative 1. For a complex number, we have two parts, the real part and the imaginary part. The real part is A, the imaginary part is B, consisting of an I. Therefore, when we're writing our answers, this standard form is considered A plus BI. Okay, then we're going to use our knowledge of complex numbers to simplify square roots. The negative inside the radical, as a reminder, becomes I, followed by root of the real number. So in example 1, we're going to write the expression in the form BI. So negative becomes I, followed by root 16. Square root of 16 is 4. So I times 4, but the proper form is 4I. In part B, we take the negative out as I, root 5. Keep it in this form. Negative becomes I, followed by root 12. We want to simplify the root without obtaining a decimal. So we break it down into 4 and 3, being that the square root of 4 is 2. So 2I root 3 be the result. Now we'll use our knowledge of complex numbers to find the sum and the difference. Be aware that our answer should be written in standard form where the real part comes before the imaginary part. Let's start with example A. 2 minus 3I combined with distributing a plus still becomes 3 and negative 4I. Then look at the terms we can combine. If you combine 2 and 3, that makes 5. Combine negative 3 and negative 4, negative 7, followed by the variable I that represents imaginary numbers. In the next one, we have a subtraction, which means we're finding the difference. In this case, we will distribute a negative 1, keeping the first complex number the same, negative 4 plus 3I. Distributing a negative 1 times 6 is negative 6. Negative 1 times negative 7 is positive 7I. And then combine the real numbers. Negative 4 plus negative 6 is negative 7. 3 plus 7 is 10I. Next one we have distribute a negative 1. Keep the 8 plus I, followed by negative 1 times negative 2 is 2. Negative 1 times 6I is negative 6I. Combine the real numbers. That would be 10I, or just 10, followed by 1 minus 6 is negative 5I. Next part we will work on is product. Product is when we're multiplying two complex numbers together using distribution. Keep in mind that when I times I is I squared, replace with a negative 1 to simplify further. Let's do some examples. 7I times 2 is 14I. Then 7I times 6I is 42I squared. Negative 6. Negative 3 times 6 is negative 18I. Proceed by combining like terms. 14I minus 18I is negative 4I. Then I squared is negative 1. 42 times negative 1 is negative 42, combined with negative 6 is negative 48. Keeping in mind standard form, we would put the real before the imaginary. Continue on to example B the same way. I times 7, 35. 5 times negative 2i, negative 10i. Negative 4i times 7, negative 28i. Negative 4 times negative is a positive 8, followed by I times I is I squared. Recall I squared is negative 1. That means we're just going opposite of 8, which is negative 8. 35 minus 8 is 27. Negative 10 plus negative 28 is negative 38i. Next part is about complex conjugates. The reason we use conjugates is so that we can multiply the imaginary number. So the product of 7 minus 7 plus I, which is the conjugate, would yield canceling the portion b squared. So 7 times 7 is 49. And then negative 1 is 1 is negative 1 squared. So 49 plus 1 is 50. And part B, remember, is the opposite of the negative 3 minus 4 5. Negative 3 times negative 3 is 9. Negative 4 times negative 16, but since it's squared, it's positive 16 is 5. Okay, so we're going to multiply the conjugate to both, and then the numerator, we get 6 plus 3i plus 4i plus 2 squared. And recall I squared is 1, so negative 1 times 2 is negative 2. Combine and negative 2, 4. Combine 3i plus 4, 7i. Now we would want to denominator multiplying the denominator. That would be 8, a being 2. So 2 4 plus negative 1 is 1, 5, the denominator. Same on this one. 5 minus 2i as a conjugate. What you denominator by, you must also do to the numerator and then distribute. As we did in product, 4 times 5 is 20. 4 times negative is negative 5. 3 times is 5. And then negative 6 squared. I squared is negative times negative 6 is 6. 20 plus 6 is 6. And negative 8 is an I. And then the denominator would be 5 times 4a squared is 5 squared. B is 2 and the denominator. Okay, lastly we have something we call quadrumula. X equals B minus B squared and 4ac over 2x. Fill in a is 1, negative 4, and C is 19. X equals opposite C, which is 4 plus minus square root B squared negative 4 minus 4 times 1 times 19 all over 2 times C. A 1. Simplify negative square minus times 9, or 4 times 19 is 6. 16 minus 76 would be negative 60. So we are plus minus root negative 60 over, and break down 60 to square root of 4, and negative becomes your I equals 4 square root. Before we square root, make sure to change the to an I. Square root of 4 by root 15 over, and divide both 4 and 2 by 2 at minus I, which would be the answer. Part B, same process. 3, B is 1, and C X equal to opposite of B, 1 minus root of 1 squared, which is 1, minus 4 times 3 times 2. So that would be 1 minus 4 times 2 is 24, so it'll be 3. Negative 1 plus negative 20, bring an I out, 23 over 2 times A 2 times a, 2 3 is would be the answer there. This concludes the notes for performing operations in complex numbers and applying it to quadratic form.